Okay, we're going to look at least parts of question 23 because it seemed like we had a lot of questions about confidence intervals. So we've got snowfall. The mean is 23.4 per inches per year with the standard deviation of 5 inches. We're going to go down here to part D. We want to find Z for a snowfall of 20 inches. So remember, the whole idea of Z is it's the number of standard deviations above or below the mean. So I don't use the formula. I just say how far below or above the mean are we. In this particular case, we're below the mean, so we're going to be taking 20 minus the mean of 23.4. And of course, that means we're 3.4 below the mean. So I want to know how many standard deviations that is. Well, it's only part of a standard deviation. Standard deviation is 5. So remember, you divide by the standard deviation. And negative 3.4 divided by 5 is going to be approximately negative 0.68. So that's Z, okay? It did not ask for a percent. It asked for Z. That's the number of standard deviations, okay? If you like formulas, the formula says take your data value minus the mean, and a lot of times they'll use a mu for the mean, and divide by the standard deviation, which is a lowercase sigma. So if you're a formulas person, there you go. It'd be the same thing, right? It would be 20 minus 23.4 divided by 5, just a little different way of thinking about it. All right, so that's part D. Let's go on to part E here. It says, in what percent of years is it expected there will be less than 20 inches of snowfall? So we're going to the table for a Z-score of negative 0.68. Let's take a look at our table here. Negative 0.6 is right here. And the 0.8 over here looks like it would be negative 0.68. Is that 24.83% in the table, I think, there? So 24.83% is what our Z value gives us as our percentile, all right? Part F, what's the probability of more than 30 inches? So we need Z for 30 inches. Okay, so 30 is above the mean, so we need to know how far above the mean it is. How many standard deviations above the mean is that? So 30 minus 23.4, that's going to be 6.6 above the mean, and that's more than one standard deviation. Divide by the mean of 5. And our Z value there is going to be 1.32. They didn't ask us for Z, but I'm going to leave it there as part of my work. So 1.32. So we turn to the positive side of the Z table. 1.32 looks like it's right here in the table. That is 90.66%. 90.66%. Now, be careful. That's the percent that would be less than 30. Okay, so if we want more than 30, we would take one, or actually I guess 100% minus that 90.66%. That would be about 9.34% of the time that you're going to get more than that amount of snow. All right, let's go on to part G. Determine the probability of receiving between 25 and 30 inches of snow. Well, I also am going to need a Z-score for 25. So let's see. So I'm going to do 25 minus my mean of 23.4. I'm going to divide that by 5 to get my Z-score. 25 minus 23.4. It's 1.6. It's a lot less than one standard deviation. If we divide by 5, maybe a pretty small Z value. Z here is going to be 0.32, so we're only 0.32 standard deviations above the mean. So I need a percent, so I'll go look at my table for 0.32. 0.32 is right here, 62.55%. 62.55% for of the time will you have that much snow or less. Okay, so if you're visualizing this, we're looking between 30 and 25. 30 was at a 90.66 percentile, which means 90.66% of the time we had less snow than that. This is at a 62.55% percentile. So we want the value that's between those two. You should be able to subtract those two. So 90.66, and you're going to subtract 62.55, and about 28. So 90.66 minus 62.55 gives us approximately 28.11% of the time. It's going to snow somewhere between those two values. All right? All right, and then part H says 67% of the time the amount of snowfall is less than what value. So we need to look up a percentile of 67%. That's over 50%, so that should be on the positive side. And 67%, oh, that's nice. Look at this. We actually have exactly a 67 here on the table. Looks like it's at 0.44. So 0.44 is our z value there. And that means we want to be 0.44 standard deviations above the mean. Okay, so one standard deviation is 5. So we want to take 0.44 and multiply by 5. And so that's going to be about 2.2 inches above the mean. And we want to know what that height is. Well, the mean was 23.4, so we can add that to 23.4, and we end up getting 25.6 inches of snow. That would be your 67th percentile. So 67% of the years you get less than that amount of snow. All right? And I think for the confidence interval problems, I'm going to do a separate video.